Yeah, welcome everybody. Give a quick overview of our new course or pilot, Machine Learning with Python. How many of you have heard about machine learning in media? Yeah, so this course title alone is a self-runner. So I was a bit disappointed that we only had a few over 100 something students.
Next time we'll go have
Next
more.
1,000. Yeah, and machine learning, I will talk in a second a bit more about what could be or what it is. Machine learning transforms our life. So many of our lives are already transformed by machine learning. Yeah, next one. Every one of us has a personal assistant. The smartphone, for example, when Mina was presenting her slides in Finnish, I still don't understand Finnish much beyond mitä kuuluu and moikka, tervetuloa. There is a Google Translate app, so I just took a snapshot of the slides and it was more or less able to identify that it's about continuous learning and related things. But also very personal, some 5 years ago I started to register at a social media platform for scientists called ResearchGate. It's kind of a Facebook for researchers. And there on this platform you get recommendations or suggestions for job openings. And one of these job openings was from a university called Aalto University, which I didn't know of. I was in Austria at that time at the Technical University Vienna. But the job title seemed interesting, assistant professor for machine learning. I didn't know anything about the university. I checked a bit if I knew a few guys from here, and I applied. So based on this suggestion, I ended up here now, 5 years later. Shortly after coming to Finland, I registered at another social network platform, and I got another recommendation, which was a match. And this is now my wife, my Finnish wife. So my job now basically is due to recommendations, which are most likely produced by machine learning algorithms. So my life, at least, was heavily influenced already by machine learning. So it's natural to try to understand what is machine learning. And in a nutshell, could I have the next one? What machine learning is about, it's about implementing one of the most simple and fundamental principles for all intelligent beings, particularly for scientists. It's about fitting models to data. We make observations. I perceive the world. Based on my perceptions, I make a prediction. I make a hypothesis. For example, if I see a lake and it's not frozen, then I predict that if I step on it, I will drown or will become wet. If I see a lake and I know it's minus 10 degrees, I predict that I might be able to walk at it. So I make predictions based on a hypothesis, and I test this hypothesis. So I validate the hypothesis. And if the validation tells me the prediction was not good, so the ice broke, then I adapt my hypothesis. This might sound a bit abstract, so let's look at a particular example. How many of you ski, cross-country skiing? Yeah, so this is Finnish. I also started here in Finland to ski, and I learned that it's highly non-trivial to choose the right wax. And the wax is very important for the joy that you have during skiing, particularly if you do a long round. So one problem that I was confronted with this year, to predict the daytime temperature based on the temperature in the morning. So I woke up, I saw it's a nice sunny day, but quite cold, so that I know the temperature at 7 a.m. on a day, but I would like to know the temperature at 1 p.m. when I'm in the middle of my 80 kilometers route. I would like to. So I would like to know the temperature so that I can adjust my wax. Does anybody of you know, is there a smartphone app that suggests you the right wax? I don't know. I mean, it's a business idea, which I'm playing around for a few months. So we have data. So where do we get the data from? Each data point here represents one previous day where we have recorded the temperature at 7 a.m. and the temperature at 1 p.m. Where do we get this data from? How do we collect such data? I mean, we can maintain a diary and write down these temperatures, but is there a more efficient way to get such data points? In the internet, yeah. The Finnish Meteorological Institute, FMI, homepage provides this data free. Yeah. So you can download tons of these data points, and then you can try to come up with a hypothesis. So a first simple guess would be a linear hypothesis. So you say if the temperature is higher at 7 a.m., then it might also be higher at 1 p.m. So this is a linear hypothesis. And what machine learning is about, how to fit this hypothesis, how to fit the straight line to these data points that I have collected. So many of you have learned about how to solve this problem maybe in high school, in mathematics. So you write down the error or the squared error terms, and you try to minimize the error terms by varying the parameters or the slope of the line. So it sounds too trivial to be the general principle underlying machine learning. However, there are nitty-gritty details. For example, how do you cope with billions of such data points which are distributed at servers all over the world? So you might not only want to use the Finnish data, but you might want to use some similar data points from very south locations, like in Chile or South America. Maybe this also helps you to fit a better predictor. Or the relation might not be linear, and most likely will not be linear here for this application, so you want to fit a nonlinear curve. This is what deep neural networks are good at. So deep learning is a special class of machine learning algorithms which fit nonlinear curves to such data points. But the basic principles is very simple and underlying any machine learning method. Try out the hypothesis. Trying out means to compute the error against some data points or to validate the hypothesis, and based on the error, adapt it. Refine the hypothesis. Okay. And what is nice about machine learning technology that you don't have to implement these basic building blocks, but they are already there. For example, in Python, which is a programming language that we choose for some reason, I will talk a bit more about this, why we choose Python. For example, in Python, there is a very powerful library called scikit-learn, which has already implemented most of the basic building blocks for machine learning algorithms. So you just pick and combine these basic building blocks to implement this machine learning principle, so to fit a curve to data points. And this is the basic idea of this machine learning course, to convince students, and I hope we get confirmed by this then, soon, that machine learning is about fitting models to data. And this fitting can be done using libraries, in Python, for example. So we choose Python as the programming language for this course for several reasons. First, it's easy to learn. It has a very intuitive syntax, and my personal opinion is, as soon as you had any prior exposure to some higher level programming language like C or MATLAB or Java, you will have no problem to learn Python within 1 or 2 weeks. Okay? So this is really easy to learn, in my opinion. It's free, so it's open source and free, the implementations of this programming language. There are powerful machine learning libraries available, that I just showed you. And last but not least, the job market cries for Python skills. So if you look at, for example, a job platform Indeed, if you look for machine learning Python, you will get a wet mouth when you look at the salaries here. Of course, it depends also how mobile you are, how much you are willing to travel. So it might not be here in Helsinki, but this average salaries per year, 100,000 euros, is not a surprise. Okay, so the market cries for it. That's why we choose Python. And now a bit about the technology of the course or the organization of the course. So it's a fully online course. There are no lectures. It kind of evolved out of my machine learning, of the regular machine learning course, which is given on a master level. and basically, or to some extent, was obtained by pruning every lecture, the lecture sessions, so the contact sessions. And what was left are the Python notebooks. We'll talk about more about this in a second. A Slack channel to provide a discussion platform, and a course book, which I started to develop. Okay, so these Python notebooks are a form of a text document, including code snippets. So it binds together source code and documentation, or also mathematical derivations. For example, I have here one snapshot of such a Python notebook for one of the assignments in the course. So we have here the explanation of the task, what the students have to do. For example, here we describe what kind of data we have, what are the data points, and here we provide them some skeleton code. So we guide them. They then, in the end, have to insert or complete a few gaps, fill in a few gaps in the source code. And in this way, we also guide them to learn the language. So we provide a lot of skeleton code or support code out of the box. And as a side effect, they will learn Python. So the course is designed also to allow students to learn Python on the fly. So Python, what should I say about the Python notebooks? What is very convenient about these Python notebooks for an online course, the students, so the user interface for the student is only a browser, a web browser. The students don't need to install anything else on their computer, wherever they are, than a browser, which is connected to the internet. The burden of providing libraries and installing the right packages is all shifted to the course administration side. In particular, the excellent IT guys at our department took care of this. So at our department, they managed to set up a server, a notebook, it's called Notebook Server, which provides all the packages. And the students access these notebooks just like a web page. And they code also in the browser. So they can edit and modify these notebooks and execute them in a web browser. Okay, the second building block or main block of the course is the Slack channel. So we organized such a discussion forum. For each, we had 6 assignments or 6 rounds. For each round, we had one channel in order to group the discussion a bit. And the students were able to ask questions there, which were answered by colleagues, by other students, or by TAs. So we had 6 TAs to help students by answering their questions and help them with problems if they get stuck somewhere along the way to solve the issue. Yeah, we had, maybe a word about the TAs. We had 6 TAs for around 120 active students, which gives 20 students per TA, which seems reasonable. So if we now plan to upscale the course, 20 to 30 students per TA is a good setting. And this, so the feedback was highly, the responsiveness of the TAs was highly appreciated in the feedback. We started already to get some feedback from the students, and the responsiveness of the TAs was one of the big pluses in the course. Yeah. We also screened the contributions of students. So if some students gave very helpful comments or hints to other students, we awarded bonus points. Okay, yeah, so the first run is just finished a few days ago. We are now computing the grades, doing the grading, and waiting till the feedback comes in completely. Yeah, and it's again this circular structure. We now executed the course, we collect the student data. We will also look carefully at, we will not only look at the free text feedback data, but also we have collected some log information from this Python notebooks. So the IT guys, they log the activity of the students. And we will also have a look at the activity of the students. For example, if there are certain times where they are very stressed, where there's a lot of work to do to redesign and reschedule the course. So again, we use the data to adapt our hypothesis. Our hypothesis here is what is the best course design, or what is the try to make it personalized, to make it as much personalized as possible for each student in the course. Yeah, some particular ideas. Yeah, I might skip, or we might skip the course book. This was one artifact, or it was there because it grew out of this master level course. But the appreciation of mathematical derivations is not as high as I thought. So we will make it even more hands-on. So more verbal descriptions or intuition, develop more intuition instead of strict mathematical derivations. Although for my case it was already very reduced, but I was a bit biased maybe. So we make more use of ready-made solutions, and we focus more on using the existing implementations, on the application of the methods. Yeah. Okay. Any questions?
And now Aira Seuna from Tieto.